At 05:15 hours local time, on August 14, 2026, the commander of a Russian fuel tanker convoy bound for Crimea was reviewing his route, with no idea that the road ahead had already been packed with large buried explosive charges. In exactly 90 seconds, 360 tons of diesel would turn into Ukraine's latest convoy catastrophe. Triggered by modified mini-drones worth $6,000 each, tasked with flying directly into those charges the instant the Russian column passed over them. 25 miles away, Ukrainian special forces from the Birds of Madar UAV unit were watching thermal imagery over an encrypted video link. Their modified Schmavik reconnaissance drone had the target locked. The thermal data coming back left no room for doubt. The diesel engines of 15 fuel tankers glowed near white at 42 degrees Celsius against the cold morning ground, while the 6 B-meat Terminator armored escorts showed subtle heat variations that told operators exactly where each vehicle sat. But this was not a rushed ambush. After Ukraine's 40-day campaign to cut off Crimea's supply lines wound down, Russia had concluded the convoy strikes had stopped. What Moscow did not know was that Ukraine's Defense Intelligence Agency, the GUR, had been following this particular convoy ever since it loaded up in Rostov, using a network of scouts with encrypted smartphones. GUR had logged its departure schedule, its average speed along this stretch, and most critically, what it would take to make the convoy stop at a precise location above the buried charges. The math was blunt. Each tanker carried 25 tons of diesel. 15 of them meant 360 tons total, enough to keep a Russian tank and armored vehicle battalion running for 3 days. Enough to sustain Crimea-based air defense units that were currently watching Ukrainian drones hit their bases without being able to respond. The fuel supply was not an abstraction. It was what kept Russian operations functional. What made the strike even harder to counter was how Ukraine had rebuilt its reconnaissance network. The Schmavik drones had been upgraded from the DJI Mavic platform by Ukrainian engineers, giving them up to 60 minutes of flight endurance and an encrypted communication system built to resist jamming. The control signal hopped continuously across 2 frequency bands, 2.1 to 2.8 GHz and 4.9 to 6 GHz. Changing frequencies at random. When Russian electronic warfare equipment tried to suppress one channel, the system had already moved to another. The drone also carried a jamming-resistant GNSS module and satellite navigation antenna, making it difficult for Russian navigation jammers to knock it off course. Both the RC link and the live video feed ran through high-grade digital encryption, so the enemy could not steal the camera feed or take control of the aircraft. That let the Schmavik interface freely with the smartphone-based Ground Scout network below, sharing and receiving data without alerting anyone to its presence. Each Ukrainian FPV in the strike package carried a PKG-3 anti-tank warhead, 2.2 pounds, built specifically for vehicles. Its shaped charge could penetrate the road surface above a buried explosive or breach the 10mm steel wall of a fuel tanker when needed, using internal pressure to rupture the fuel compartment. The mechanic was simple: a small needle, a very large balloon. The convoy rolled through occupied territory at a steady 30 miles per hour, unaware that in under a minute, this routine logistics run was about to become a case study in why Ukraine had been so effective at cutting Crimea's supply lines. At 05:16, as the Russian column closed to within half a mile of the ambush site and the Ukrainian attack drone came into its final approach, the electronic picture changed. An R-330ZH Jetel electronic warfare system mounted on a Kamaz 43114 truck inside the escort formation powered up. It immediately saturated an 18-mile radius with jamming energy, targeting communication signals and satellite navigation frequencies that Ukrainian drones depended on for positioning. That was also the reason Ukraine had not used a remote detonation method. The jamming environment made it necessary to send an FPV directly into the charge instead. The Jetel is designed to detect, analyze, direction find, and suppress signals between roughly 100 and 2000 megahertz. Its primary interests include cellular networks, some satellite communication links, and the satellite navigation signals drones use to know exactly where they are. For ground-based communications, it targets GSM 900, GSM 1800, and GSM 1900 networks. Seconds after the system came up, the position icon on the Schmavik control screen began jumping. Coordinates flickered, while speed readouts no longer matched what the camera was showing. Ukrainian engineers had already written a response for this. When GNES data degraded, the flight controller automatically cross-referenced it against the drone's internal inertial measurement unit. Gyroscopes and accelerometers tracked every change in speed, heading, and attitude independent of any satellite signal. If GNSS showed the drone drifting dozens of meters while the inertial sensors recorded zero corresponding movement, the system flagged the satellite data as compromised. More importantly, the Zytel had not yet cut the Schmavik's video link. A system that can suppress GPS or GLONASS does not automatically kill a video feed operating in a different frequency band or using different power levels and modulation. The Birds of Madar operator could still see the convoy and flew the drone on visual reference: the road surface, the tree line, intersections, utility poles, the convoy formation itself. GNSS jamming cannot remove landmarks from a camera feed. The Russian side pushed jamming power higher. Some cellular coverage in the area began breaking down, and several Ukrainian ground scouts temporarily dropped their connections. But it no longer mattered. The convoy's route, speed, and formation had been transmitted to the strike team in advance, and the Schmavik was still watching everything. You can jam GPS. You cannot jam a frequency that keeps moving before you can lock onto it. When the R330ZH increased output, the FPV's transceiver shifted its control link down into the 400 to 700 MHz range, where the Russian system's energy was more spread out. The control link also ran a frequency-hopping spread spectrum mechanism similar to modified Express LRS configurations, switching channels hundreds of times per second. That meant the Zytel could not simply detect a UAV signal and park jamming power on it. It had to locate the signal precisely, separate it from background noise, then concentrate enough energy on the correct slice of spectrum before the signal relocated. Ukraine kept moving the door before Russia could close it. For the Madar operator, the whole thing played out in near real time. Video quality dropped, latency climbed, some frames broke into interference blocks, telemetry flickered on and off, but the control link held. The operator tracked by what was in frame: the road running down the center, the tree line to the left, utility poles running parallel on the right, and the line of vehicles growing in the camera as the FPV closed the distance. Ukraine did not need to overpower the Zytel. It only needed to outlast it for a few more seconds. An electronic warfare system covering an 18-mile radius has finite power. The wider it spreads that energy, the thinner jamming density gets on any individual frequency. And for an FPV seconds from its target, a minimal link was enough. At 0518, inside the Kamaz, Russian operators kept scanning the spectrum and increasing suppression, expecting the video feed to freeze and the drone to lose control. That was normally what happened against commercial UAVs on fixed links. The lead FPV was racing toward the convoy at 100 miles per hour. The operators had just discovered their problem. They could make the drone's GPS useless, but they could not take the operator's eyes off the target. A multi-million-dollar electronic warfare system had just been neutralized, for practical purposes, by a $6,000 drone and a creative frequency-hopping algorithm. At 0519, Ukraine's lead FPV accelerated to 140 miles per hour, passed the front of the convoy, and dropped to 15 feet above the road surface. Less than 4 seconds later, it hit the first buried explosive charge almost dead center. The 2.2-pound PKG-3 warhead set off the 350-pound charge underneath, hurling hundreds of pounds of road material skyward and gouging a crater 60 feet wide and 6 feet deep directly in front of the lead fuel tanker. Then the convoy's situation got worse very quickly. The armored vehicle at the front and the lead tanker, both moving at 30 miles per hour, braked hard. The 25 tons of diesel behind the cab kept pushing the vehicle forward under inertia, pitching the truck nose down before it stopped roughly 50 yards from the blast site. Within 10 seconds, the vehicles behind were compressing together on the narrow road. The 6 B-T Terminators immediately spread into a defensive perimeter. But the first explosion had already served its real function. It had determined exactly where 360 tons of fuel would be forced to stop. On the Schmavik thermal feed 25 miles away, 15 diesel engines were now showing as a single bright heat cluster in one location. What the Russian crews still did not know was that directly beneath the middle of the convoy, the second, and much larger, explosive charge was waiting. The next FPVs appeared above the tree line 6 seconds after the first explosion, but they did not dive toward the second charge. Doing so would have given its location away. Instead, the operators adjusted mid-approach. One drone turned toward the convoy's center, 2 more swung toward the flanks. The rest dropped below 50 feet to force a reaction from the escorts. That reaction came immediately. The 6 Terminators opened fire. Each BMT carries 2 30mm 2A42 autocannons with a combined cyclic rate of around 1,000 rounds per minute. Turrets swung between fast-moving targets, crossing at over 100 miles per hour. The first FPV detonated in the air. The second came apart above the tree line. Then, the third. Within seconds, 6 FPVs had been destroyed by cannon fire alone. The escorts used everything on hand. The 7.62mm PKTM machine guns swept low across the fuel tanker rooflines. 3 more FPVs tried threading the gaps between Terminators and were shot down one by one. In under 30 seconds, the airspace above the column had become a layered wall of fire from autocannons, machine guns, and AK-74s carried by Russian infantry who had dismounted and moved close to the Terminator hulls. Some carried Saiga 12 shotguns and worked any drone silhouette that broke through the smoke. For Ukrainian operators, each FPV had a lifespan measured in seconds. They flew erratically, climbing and diving, side-slipping, hugging the road, while the R-330ZH continued hammering the video feeds from behind the formation. One FPV hit the 6th tanker's fuel tank, tearing it open and spilling diesel across the road. Another detonated behind the vehicle beside it and scattered the infantry nearby. The Terminators kept traversing between both flanks. The tanker drivers tried to reverse, but had nowhere to go. The first blast had sealed the front, and the bunched formation sealed the rear. For a moment, the Russian crew had reason to think they were holding. 6 FPVs destroyed by 30mm, 3 more taken by machine guns. 9 drones stopped before reaching the fuel. But by that point, reaching the convoy was no longer the objective. On the Schmavik thermal display, all 15 tankers had compressed into a single dense cluster directly over the spot GUR had marked on its maps. The 6 Terminators had pulled in tighter to form a protective ring. The infantry was concentrated between the vehicles. And under the road, directly below them, the second charge had not moved. Russia had just used nearly all of its reactive firepower against targets in the sky. The real threat was underfoot. At 0520, the Ukrainian operator checked the thermal feed one final time. The convoy had stopped precisely where intended. The formation was compressed. All 6 Terminators were inside the kill zone. Everything that had happened in the past 4 minutes, the first explosion, the diversionary drone waves, the FPV harassment runs, had been aimed at producing exactly this picture. At 0521, after the 6th tanker took an FPV strike, thick black smoke started climbing from the middle of the formation. The remaining FPVs flying through it fought convective turbulence that shook the lightweight frames violently enough to force operators onto pure visual control. No telemetry reference, just what the forward camera showed. Battery levels on several drones had dropped to 15% after minutes of low-altitude maneuvering, jamming resistance, and constant altitude changes to avoid fire. The 10 surviving FPVs split. 8 climbed to 300 feet, rose above the smoke column, and fanned out toward both flanks, presenting the appearance of a new attack wave coming in from multiple directions. On Russian crew screens, 8 signals appeared almost simultaneously from different bearings. The response was exactly what Ukraine expected. Every weapon system below pulled toward the airborne targets. While Russian guns tracked upward, the final 2 FPVs dropped to grass level on opposite sides of the road. Their cameras could barely show anything beyond grass blades at the bottom of the frame and the convoy's wheel line at the edge. They accelerated toward 80 meters per second. At that height, the fuel tankers formed a solid metal wall that hid the drones from observation on the opposite side. The first ran along the left drainage ditch. The second hugged the right grass verge. Above them, the decoy wave was being dismantled drone by drone. When the 7th was shot down, the last surviving aircraft from the 8 drone group flew straight into the center of the formation, forcing 2 nearby Terminator turrets to rotate toward it simultaneously. That was the opening. Inside the smoke, no crew could clearly track 2 objects moving just above the ground. On the operator screens, the second fuel tanker filled the entire frame. Below it was the section of road GUR had flagged weeks earlier. The 2 FPVs had only seconds of flight time left. They made their final corrections and hit almost simultaneously. One from the left, one from the right, both striking the explosive area directly beneath where the second fuel tanker was sitting. The 2 2.2-pound PKG-3 warheads triggered the 750-pound charge buried there. The road lifted almost instantly, then fragmented into thousands of pieces of asphalt, rock, and metal. A debris column around 60 feet high shot up through the center of the formation. The blast wave spread in every direction within 1 second. Near the epicenter, pressure was sufficient to shatter glass, tear through thin metal, and compromise structures that had never been built to absorb an upward detonation. The tanker above the charge was lifted off the road surface before its fuel tank was ripped open. Then the second explosion started. Dozens of tons of diesel atomized into a hydrocarbon mist and ignited almost immediately. The first fireball pushed through the gaps between vehicles at temperatures that likely exceeded 1,000 degrees Celsius, enough to blister paint, ignite tires, and rapidly weaken aluminum components. The second tanker vanished into the flames. But it was only the start of the chain. The vehicles that had been compressed to within a few yards of each other were now connected by burning fuel. Diesel flowed across the road, ran through drainage channels, and spread beneath vehicles farther back in the line. One tank superheated, then the next. Secondary explosions rippled down the formation. 1 vehicle, then 3, then 6. Then the entire central section was a wall of fire. 12 vehicles near the burn zone were drawn into the chain reaction. Some tanks were breached directly by fragments. Others were engulfed from the outside until valves, pipes, and fittings failed under heat. What had been an organized supply convoy minutes earlier now looked like a burning scrapyard. The 6 Terminators that had moved into the center to protect the column were now surrounded on both sides by burning fuel. Electro-optical systems, antennas, external cabling, and sensor packages began taking direct heat damage. The vehicles that still had mobility tried to reverse, but the road ahead was cratered. The rear was blocked by burning tankers, and both flanks were filled with fire and debris. Moscow's resupply convoy was now an obstacle blocking the very road it had been meant to use. The deeper consequence was not the burning wrecks. The roughly 360 tons of diesel on that convoy represented thousands of hours of runtime for military vehicles, generators, and logistics units operating behind the front line. Fuel does not appear in Crimea on its own. Every liter destroyed here has to be replaced by another shipment, another route, another convoy that has to accept the same risk. The strike did not just destroy equipment, it added time, cost, and exposure to every Russian logistics decision that followed it. This is not simply a war between tanks and drones. It is a war over fuel, time, and the ability to sustain operations. Destroying one supply run today can mean a Russian unit running short next week. If you want to help the people of Ukraine, look into transparent humanitarian relief organizations focused on protecting civilians. And let us know in the comments, in your view, what decided this operation? The FPV diversion, the electronic warfare countermeasures, or the planning that forced the entire convoy to stop exactly over the ambush point?